Hello, everybody. By popular demand, How Does It Even Work is back. This time, again, with MacLemon. And this year, we're going to do fonts and typography. Thank you.
Thank you so much for having me. Hi. That battery is probably dead. Okay. I'm MacLemon. I'm on the internet. If you want, as usually, if you want to toot or no, Twitter's not a thing anymore. If you want to go on the Fediverse and talk about this, please use BalCCon2k24 hashtags and what the font, so I can find what you're talking about while I'm talking about this. So, fonts and typography. Disclaimer, this is not an exact science. Probably not a science at all. Some terms are used differently in English and other languages. Some are mixed and intertwined. Some knowledge is disputed. It's abused, incoherent, and confusing. It's not you, it's the topic. So, fonts, they're an important part of communication. And communication is hard. Good communication is even harder. And many forms of communication are quite lossy. So, in the sense that the message sender cannot entirely be ensured that they convey all the meaning they intended to a recipient. Most importantly, as Paul Václavic, an Austro-Hungarian philosopher, said, you cannot not communicate. Yes, that's a double negation. It's impossible not to communicate. You always communicate, even if unintentional. So, it's about telling stories, and this is what I do here. I tell you a story. And telling stories is a lossy way of transferring knowledge about slayed dragons and fighting creatures at the sea at storm. So you're encouraged to dive deeper into these topics that we cover. And fonts and typography certainly are the kind that has rabbit holes within rabbit holes. And you might find a rabbit hole within a rabbit as well. I cannot guarantee that, but be prepared. So, precursors to writing. Several tens of thousands of years ago, communication was immediate. You were talking to each other. There were no persistent records of communication. Pictures were drawn on cave walls. Most famously known cave drawing in Indonesia and in Europe, the El Castillo cave, 40,000 years ago. Communication got more complex. Languages became richer in abstraction and harder to convey as a painting. The pictures, they were close to reality as much as possible. So they talked about the immediate surroundings, animals, vegetation, the weather. But they were slow to paint, and a cave wall isn't necessarily very portable if you want to take a good story with you. And so about 10,000 years ago, many cultures independently began to write down things and develop elaborate forms of persistent recordings. So about 3,000 to 5,000 years ago, proto-writing evolved. You may have heard of cuneiform, imprints on clay with a stick. There's Chinese inscriptions on shells, Egyptian hieroglyphs, and these ideograms, they conveyed ideas or concepts rather than words. So what are the use cases for writing down things? You keep track of livestock inventory, like how many animals of a type do you have? You're trading goods and for commerce, and recording of wealth. And that's probably the last known time when capitalism brought anything good to the world. Another use case was laws. So enabling bureaucracies and asymmetry of power in society. There's over 30 different writing systems, and the Latin Roman one that many of you, I guess most of you are familiar with, is just one of those many. Some are based on letters, some leave out vowels, some leave out consonants, others are based on logographs, syllables, some use mixtures of those, And there's a few other special ones. You may know the Latin alphabet or writing system. It's available in Unicode. Many languages do use it, and there's only a single letter that is common to all languages that use the Latin alphabet. It's A, Aleph, Alpha. All the other ones, they leave out one or a few others that they don't need. And they substitute them with a few they do need on top of the ones that are available. All of these are available in Unicode. And yeah, you might recognize one or the other if you speak other languages than English or Serbian or whatever you speak or know about. There's also overlays over existing letter shapes. So you have a letter and you put something on that letter, like directly connected. And there's also diacritics, which are disconnected from the letter. There's a ton of them. These are just a few. They're all available in Unicode. The city where I live in is Wien, or as many of you say, Pécs. Can be written in different ways. If you write it in Magyarul, in Hungarian, you have a diacritic. If you write it in Srpski, in Serbian, there's another diacritic, unless you write it in Cyrillic, because Kyrillica does not have any diacritics at all. There's none. Interesting aspect. Also in Unicode. There's Ivrit, Hebrew. It's a system that is written from right to left, so the other way around to what many of you are used to. It's a so-called abjad system, which means it's consonants only, it leaves out the vowels. The lower line of those two, it says Aleph Bet Ivri, which means Hebrew alphabet. And the vowels are there, they're only used when you go to school or if you're doing like fancy poetry. Normal writing, these are left out. There's a traditional Mongolian script. It's a letter alphabet. It goes from top to bottom. I will not try to pronounce this. I have no idea how it works, and I will not embarrass myself with that one, just with the rest. And the next line to those goes to the right of it. So you have right to left ones, right left to right, top to bottom. There's Japanese kana. It's a syllable alphabet. It's actually two. And they usually go from left to right, unless they don't. When they're used to augment kanji, they can be written top to bottom. And they show you how to spell that character that you don't know about, so you can look it up. And if you mix kana in between kanji, they follow the direction the kana is written in, the kanji is written in. So if you write kanji from top to bottom, you write the other alphabet top to bottom as well. But kanji can be written in three directions. So when confronted with a block of text, you need to figure out where it starts actually, and it can go multiple ways. And Japanese people also intertwine Latin alphabet text in between those, and it follows the kanji direction. So be prepared to turn your head around. There's also the International Phonetic Alphabet. It tells you how to pronounce a word. So it builds vowels, it builds sounds by writing them in a certain way and pauses. It's available in Unicode. And then there's forms of communication that don't have widely available written equivalents. For example, signed languages. They're made up of a hand shape, of a position in 3D space, and of a movement and timing and metadata and mimics. How do you write those down? You can't. There's attempts, but all of them leave out many aspects of a signed language. So you cannot write down everything. These were just a few examples of writing systems that humanity has brought up. It's complex, and we'll mostly stick to the simple form of the Latin alphabet since most of you are used to it. There's many more. And let's look at the reproduction of scribe. Writing was done by hand historically, on carved bamboo, by a reed or bird's feather, cut and ink. And written records were a means of empowerment and enabled the reproduction of information without loss and interpretation of speech. So they were enabling the creation of democracies, because now you could write down an idea and compare it to another one. That's a great thing. Then people started printing letters. They took a slab of wood, cut out a whole page, and soaked it in ink, printed it on papyrus, or later the much cheaper paper. And that sped up reproduction of print and pages, information. But you cannot backspace on a slab of wood if you make a typo. So they're hard to correct, which is inconvenient. But having more written stuff available also increases literacy within people, because they're interested in, like, what's there? And then, since wooden types, they don't last long, somebody came up with the idea of, let's replace religious monks with metal pieces that we can use to print, and dismantle this concept of printing a page into atomic objects like letters. And that person was Johannes Gensfleisch zu Laden zum Gutenberg, also known as Johannes Gutenberg. He lived in the city of Mainz in Germany, and this invention was way ahead of its time. Not only did they invent movable letters, single letters, they also included page margins, columns, printable space and leading, like the space between lines and all that stuff. And they tried to carve them from wood, and pretty much like, no, this doesn't last long enough, we need to cast metal. So that's what they did. And now we have an idea maybe where a blogging system called Movable Type got its name from, or Project Gutenberg, which is Google's effort to scan books in the public domain and make them digitally available to everyone. There's this case of two cases. You have a box, there's your uppercase letters, the large ones. You have a second box with the lowercase letters, the small ones. And the lowercase, the box, you take the small letters, because you need them more often, and you don't want to reach up all the time. So it's literally the upper case, as we call it, is the physical uppercase where you grab the letters from, and the lowercase is the other one. Yeah, we still carry that legacy. And since uppercase is very important, we celebrate International Caps Lock Day on October 22nd. Yeah, it's just a month away. Have fun. The printing press and the metal matrices that could accurately reproduce many sorts of letters. They also have a very uniform appearance opposed to handwriting. So the first font, as you may call it, the first typeface is called black letter, or Gutenberg Bibelschrift, it's called as well. And this was, of course, strongly inspired by the handwriting people were used to and reproduced that. This was in 1440, so that font is quite old, I'd say. Yeah? And within the next 100 years, or up to the 16th century, type foundries emerged across Europe. A type foundry is a bunch of people who create a typeface, a font, who create letters, decide how they should look like. And yeah, that went on for a few hundred years, and in the 1980s, the desktop revolution with digital typesetting, all hell broke loose. So what do these type foundries create? Well, types, and they can be classified roughly. Caution, there's a rabbit hole in there. I'll just cover the most important ones. There's serif fonts. They have these tiny little feet and things that stick out, so they can tip over. And they're used on paper printing, high-resolution printing ways. There's slab serifs, where you just blow up the serifs like they're really huge. They're not really usable for tiny writings and body text. They scream for attention, so use them for headlines, something in between. But they still have these, I don't know what shoe size that is. It's large. There's sans serif, coming from the French word sans, meaning without. So yeah, they don't have serifs. It's also known as grotesque. So, see, no serifs. There's also script types or handwriting types. They imitate handwriting and artsy, playful linking of letters, like you do when writing italic by hand. And there's decorative fonts, They're for headlines, for posters. They're not really meant to be nicely readable at a small size, because like these three, they look very similar to each other. But for a heading or a single word at a large size, they work well. And there's a lot of them. So typefaces. You may recall a few of those names, like Helvetica. Heard of that? Yeah, it's everywhere. It's literally everywhere. Times New Roman, the default in Microsoft Word for like 2 decades. It's still ugly, but yep. There's Courier, the famous Comic Sans. Wingdings, exactly. You win something. And there's, for example, BlackPast, which is this year's BalCCon typeset, as you can see in front of the table there. Types also come in families. Yep, they're a friendly bunch. They come in families. So type foundries in the 1700s came up with the concept of a family, like create one typeface, like very upright standing Roman typeface, and then add an italic one that shares the same properties and style. So they can be italic or oblique. Those two terms are used interchangeably. They do have differences. I'll not go into that, another rabbit hole, but there is a difference. There's bold, there's condensed black or ultralight italic or monospaced. So it gets convoluted and hard to grasp over time, but fonts do have more properties like weight. I just did not call that font fat. Sorry, I don't do that. But they come in different weights, from ultralight to heavy and black. They also have different proportion, like how wide are the letters, from compressed and condensed to expanded. And a Swiss type designer named Adrian Frutiger, there's also a typeface named after them, which they created, came up with a numbering scheme in 1957 and said, well, this should be more logical and easier to understand. So they said, well, let's use 2 numbers, weight and proportion. The numbers for weight go from 3 to 9, and they denote how heavy a typeface is. We've seen weight. That's okay. Proportion, it combines 2 meanings into a single digit. Odd numbers means it's a straight up standing font, while even numbers mean it's italic. And lower numbers are expanded, and higher numbers mean it's condensed. Yeah, so weight and proportion. So if you see Helvetica Neue LT75 bold, from the 75 you can derive all those things. The typeface name is Helvetica, its weight is 7, which is bold. Its property is 5, which is odd, meaning Roman typeface in regular tracking. And the font is the actual thing that you can select in your software. That's what we use. We name a font. Fonts come in different sizes. We know size matters. And it's an important property of writing how large your text is. And with a printing press, you had to cast each size in metal individually. So you had a few select sizes available, like 37 of them, and they all have nicknames to remember. We'll go with numbers because they're more easy to use. But what actually do you select when selecting like a 14-point font? What does that 14 mean? Well, it's the so-called cone height. It comes from the movable types that are used in a physical printing press. This is a printing cone. Yeah? You see the letter F is on there, and the cone height is this length. So there's the height of the capital letter, then some margin to the top and to the side, some margin to the bottom, and the minimum line spacing to the next line. It's a completely arbitrary number, and that is also why fonts of the same number size are not equally tall, and they never will be. This is the legacy we carry since 1440 in modern desktop typography. Yeah. I hope this helps you at least to understand why this is not working out. Typographic units, like of measurement, of height and size, they come in different names. historically since the 1700s. There's inches. These are not US-American inches since typography started in Europe. These are not UK inches since typography started in Europe. They are Royal French inches, which are based on the pied du roi, the foot of the king. And in metric units, that is 27.07 millimeters to be exact. There's a movement to replace this with metric, and it's completely ignored. So don't expect anything that makes sense in the future. What does a font face look now? What's the anatomy of a font face? Yeah, if we like cut it open and look at a few most important measurements, there's a baseline. In a Latin-based alphabet, there's a baseline. It's a floor that all the letters can stand on. There's other ones, other systems that they have a line where letters hang down from, like a sloth. So we have a lowercase x, and the height of that x means it's the x line. It defines how high a small letter is, a lowercase letter is. Then you have the capital height. That defines how large an uppercase letter is. Then these are uniform across the font usually. Then you have a stroke, which means it's a vertical or diagonal main line in a character. And it defines a principal part of a letter. If it's a vertical or capital letter, a stroke can be called a stem, like a tree. And there's some letters that go a little above that cap height. They're called ascenders because they ascend above, like an F or an L. They go a little higher than a capital letter. And then there's also ones that go below, which are the descenders, like a P or a G. They have something dangling down there. Yeah, and those lines give some space where to go. And they cannot go beyond that because then your physical metal slab is like, there's nothing more. So you can't go beyond that. There's a few more things, like if you have a hole in them, there's a counter. If the hole is not closed, it's called an aperture. If it's curved, it's called a spine. There's a crossbar and a horizontal bar. It can be an arm or a leg. And if in the middle of an E, it's a tie. And if it's a bowl, it bulges. And if you have an E, then the I, the counter of the E is called an I. And if you take the letter I, the dot above it is called a tittle. And there's more of those. These are, I will not do this at the test at the end of the talk. But there's more to like how letters can interact. You may have heard of ligatures. Yeah. Take a letter F, like very nice scripted F. Put an F next to it, it looks odd. It just doesn't feel right. So some fonts have ligatures that know, oh, there's an F and another F. Let's make it nicer. Let's connect those a little more. Or an F and an I, because you have that F and a dot and there's lines in between. Let's connect those. Looks nicer. It's more easy to read. There's more complex ligatures that go across like 3 letters and still combine them in an individual way. If you have 2 applications, one that supports 3-letter ligatures and another one that does not, you can copy and paste and lose letters in between. All the Inkscape versions were very prone to this. I've searched for hours where that second F went. I was literally questioning if I'm too dumb to copy paste. Yeah. So if you're missing letters when pasting, check those things. Then there's white space. If you can't read that, it says white space. That's all that is not letters. Is white space. This is not a discussion about tabs versus spaces. It means the space between words. Yeah? There's multiple variants of different sizes. If you remember the emoji talk, there's white space that has an exact width of 0, which is not a lot. But there's other types of white space. There's the so-called tracking, which is how wide a font runs. How long does it run? It's the default spacing between a pairing of letters. But there's individual spacing between letters as well. It's called kerning. For example, if you take a capital A and V, if you put them side by side, like with an exact line, it looks odd, but you can move them a little closer, so it makes them more comfy. They cuddle together because they're friendly. You could do the same with capital letters and lowercase letters. Like this A could move a little under the arm of the T, which looks nicer. So I'm really sorry I told you about kerning, because now for the rest of your life you will see when the kerning is off somewhere. Sometimes like 5 or 6% is enough to make things really look bad. But there's other types of white space, like line spacing. It goes between lines. It's measured from baseline to baseline. You know what the baseline is now. And if you reduce it, yeah, you can you want to tuck in a little, and it can easily become way too much. That's also like 5%. But you recognize that this is, can breathe a lot. So some say white space is even more important than the black letters themselves. That depends on what you write, of course. But take the time, talk to professional layout people and type designers, if you dare to. So there's a lot to know about seemingly nothing, but that nothing is important to make your something be worth anything. What are use cases for typefaces, for printing? You can print in 2 dimensions on paper, or a sticker, or a t-shirt. With a laser printer, you're basically rasterizing to black and white. If you have a color laser printer, you have basically 4 black and white printers in one, with cyan, magenta, yellow, and K, meaning contrast, which is written with a C, but that's already taken by cyan, so we take K for black, obviously. CMYK as a processing color. Yeah. With inkjet printers, it's the same, only the ink dries up, which the toner doesn't. And 2D printing is usually a high-resolution process, so little details like the tiny feet of serifs, they show up very well on paper. Then you have computer screens. They require a little different font choice because usually most are lower resolution, like historically 72 dpi, modern retina screens of your laptop or phone, which you're watching much closer, they have higher resolutions. And a TV, if somebody still has one of those, they usually don't need that high of a resolution. Then, let's add a dimension. You can 3D print text. Like the letters there, they're printed, 3D printed. And there are many things that make a font suitable or not suitable for 3D printing that are not obvious. Like a font may be fine to print on paper, but impossible to print in 3D. Because depending on the orientation of your print on the bed, they may work or not at all. And if there's an invisible path in the geometry of that font, you might not notice it when printed, but it may wreck your geometry in 3D. And you're suddenly missing parts of a glyph, like parts of a character. There's a hole inside that's not supposed to be there. So if you're 3D printing, oh, I've got an example. Yeah, the BalCCon text this year, it uses a font. And if you look at that font, that's a C, a lowercase c. See any problem with that? There's a gap. So if you 3D print that, you have 2 separate pieces that are floating. Yeah. So when 3D printing, there's more aspects to the quality of a font. So if you want to put a label on your 3D printed case for a device that you're making, you can print text directly in 3D onto that object. And I've brought a few sample cards that show you how good fonts in the blue cards, usable ones in green, more problematic in yellow, the orange ones and the red one please don't use because it's missing parts of letters. I can hand those out. Have a look at them, feel them, see how 3D printed text can look like. There's other types of text that you can 3D print because they're not ink. How about Braille? You cannot only read visually, you can read by tactile means. These are Braille cells. They're movable. You can move I think the technical term in German would be Nupsi, the white pieces. You can move them. And these are meant to learn Braille or leave a note to another person. Like you have 8 letters on the Braille cell, this one. And they're printed in flexible material, so they are nice to handle. They move a little. We tried it in rigid, not as nice. When printed on paper, or actually on the paper, Braille is embossed from the bottom. And you can 3D print a portable Braille typewriter on a string. You can use these, clip it on a piece of paper, squeeze them together, and then you can write Braille. There's something written here that you can feel. And if you want, you can continue writing there. So, reading, maybe visual, maybe tactile. Your brain recognizes the shapes of letters. And if you're an advanced reader, it starts recognizing the shapes of words, like the skyline of the letters, and the beginning and the end. You know the famous thing where you can flip around letters and disorder them, and your brain still makes sense of it, mostly. It's an extraordinary skill the brain can have. But there's also a more general term for letter or character. It's called glyph in typography. And it means any meaningful mark, any purposeful mark in writing. It can be a mark like a question mark, or any punctuation, including the famous interrobang, which is a combination of question mark and exclamation mark. It can be an A, and you have these diacritics, and they're combining, so you get this little colored thingy that tells you the next letter may go underneath that diacritic thing, if it's allowed to go there, and the font needs to know about this. For example, the tilde, which is used in Spanish and Portuguese, they may go on N and A and O, but not on E and I. The font needs to know this. It doesn't know which language it's typing, but it knows the rules, and so do I. There's more diacritics. You may be familiar with some of these, of course, as well, and which are used as language dependent, but there's also digits. How many digits are there? Let's go simple with the decimal system. How many digits? 10. There's always 1 digits in any system, but yeah, for decimal that's 10 digits. In typography there's more. Like what more? How do you do more digits than 10? It's not hex, it's all letters. Well, there can be monospaced digits, like if you have a calculation, you want to align the digits in the rows, because otherwise you get confused and your financial statement may cause questions. For inlining numbers with text, you can use proportional letters or numbers, digits. They are of different width, but they make it easier to read when they're in a line of text. And as you can see, the ones are much slimmer than the other digits. And there's also medieval digits that are not all the same height and all on the baseline. They have ascenders and descenders. In 6 and 8, they go above, and 3, 4, 5, 7, and 9, they go below. And they also help with reading when in line, but they're unusable in a spreadsheet. They make you go crazy. But you can have more variants of digits. Like you can have an open or a closed 4, or a round and a straight 6 and 9. And many fonts do have these available in typography. In a good text program, you can select them. In CSS, you can select those properties. Yeah, I see faces that are like, what the font? Yes, you can. Make use of those, because you can immensely improve readability of your text. So, fonts are describing symbols, they are describing glyphs, and how they behave and relate to each other. Historically, fonts have been proprietary pixels in some ROM module of a computer. They were proprietary because there was no need for interoperation, and the time was like, get this to work at all. So monochrome pixels it was. Then it became vectors, still proprietary, but a need for interoperability arose, so then we had interoperable vectors. Like, you have heard of PostScript, which is something that Adobe invented in the 80s. There's two main formats, type 3, which has programming features like loops and variables that you can use to describe your text or letters or glyphs. It does not have a standardized way of hinting how to adjust something for a very low resolution like a screen, because you might not hit a pixel or not hit a pixel, and then you need a strategy. Do I follow the shape or do I follow the pixel boundaries of my screen? And there might be different ways. Windows follows the pixels, macOS follows the shapes. The higher the resolution is, the more the shape becomes important, so you might get used to those. And there's PostScript type 1 fonts. They were simplified in some way without loops and variables, but with standardized font hintings. So how do we combine those? It was proprietary by Adobe, it was patented, it was expensive, and Adobe did no move in making this cheaper and available. So Apple said, we're doing our own. In 1991, invented TrueType and also licensed that openly to Microsoft. Lots of drama with Adobe ensued. But Apple's classic macOS 7 was, System 7 was the first one to actually scale up to any size. Continue a few years, there's OpenType with Microsoft and Adobe and other ones now. And it's an ISO standard by now. And OpenType is 30 years old now, so it's not new. Your system should support this, and you should make use of typographic features. The new thing, which is almost 10 years old, is variable fonts, and they can contain multiple typeface families, weights, and glyph variants, and all that stuff in a single file, so you need to import one font file into your web page, reduce loading times a lot, and make use of all those properties by font variation settings in CSS3. So, damn, they're there, use them. Really helps. There's legal aspects to fonts, of course. What are fonts? We heard there's loops and variables, and what can we do there legally? Well, we can protect the typeface name. That's easy. It's just a name. Okay. Can we protect the design? I mean, how do you protect the letter A? It's difficult, so there might be some discussion. Our fonts code, I mean, they have variables, they have loops, they have statements, and make decisions on like, what's the next letter, what's the letter before me, do I make a ligature? And if you want to use other people's fonts, you either have to buy them from a foundry, and a good font can be very expensive because it contains tons of glyphs, like several tens of thousands, to like really make use of it. So that's why they're expensive. They take a whole team several years to create, like full-time jobs. But there's also open font licenses, like fonts that you can just use for anything. Because there's a problem when creating a font and you protect that font. Does the document you use to and write that font in, does that protection of the font leak out to your document? Is your document now protected? And the owner of the font or the creator of the font has some legal rights to your text? It uses their glyph. Yeah, it's difficult. There's some you can use for free, which are under an open font license. For example, Google fonts. You do not need to load those from Google, import those to your own server, respect the privacy of your viewers. There's even tools from Google to help you do this. There's Noto, there's Roboto, and Ubuntu fonts. There's many others. Have a look at them. There's also security aspects. I know BalCCon is a security-focused conference. Typography, probably not, or is it? Fonts are Turing complete by design, not by accident. There's been many incidents of IT security problems with devices rebooting, getting rooted, implementing whole CPU architectures in a font that can be exploited over the internet. You load a web page, you load Turing complete code that is executed by your operating system's font shaper engine. And in Windows, that is part of the kernel. Are you scared yet? If not, why not? So, to give you an overview of typographic features that a modern variable font exposes. Think of this as an axis with a slider that you can move across some digits, some numbers. For example, weight. Pull the slider to the right, becomes a heavier font. One axis. Fonts are multidimensional. These are a few of the properties that are exposed. I would probably bet a lot on that not each and every one of those is input validated properly and securely in every font rendering engine and typesetting system on any OS. So if you're looking for a attack surface, remember a few of those. Look those up. There's a lot. Fonts can also have an environmental impact. Like, what do you mean environment? Yeah, don't print things. It's the easy thing, and some people put it on their email signature. Like, why do we email at all? The second best you can do is reduce the font size a little. You might save a few pages. Use a thinner font. It will save you on toner. And there's companies doing calculations on that and recognizing they can save 6 figures a year by changing their default font. If your company is a little smaller, it might not have that much of an impact, but there's something to consider. And if you're doing a lot of internet web thingies, you can optimize your font loading times for traffic. You can save terabytes, even if you're not Google scale, because they have optimized their logo to be as few bytes as possible when transferred over the wire. They adjusted their font not to look nice, but to be cheap to transfer. But if you do that a gazillion times a second, it adds up. There's also accessibility aspects to fonts. Not only because you have legibility and readability of different font properties that make fonts easier to read and use something that's appropriate for the use case, like headlines or body text, like longer reading stuff. And if you say, well, a screen reader does not read fonts, it reads the bytes of the text, unless it doesn't. Because you can, these days, you can take your phone, hold it up to some sign on the street, and it will read what's on that sign. It may even translate to another language. It reads that font. It actually reads that font. And if that is a badly readable, badly legible font, that may affect a person that wants to read what's on that sign. So it's something to have in mind and make, for a random person on the planet, have a better time quite easily. There's also entertainment. I might have mixed up a few slides here. Let's see how this goes. Yeah, those are mixed up. I'm sorry. For games, there's a game called Typewriter. It's about typography. And you are the protagonist of the game. You're a colon. This is the character you play through all the game. And as usual, it's like a 2D jump and run style game. You have different worlds, like the worlds of serifs, the worlds of sans serif, the world of pixel fonts. These are levels. All these are words of, yeah. It's really beautiful. It's very nicely made. It's actually a nice game. Not only aesthetically, it's also good to play. There's Typoman. where parts of your world are typography, like the platform that says, "Hi, I'm a platform." And there's a cloud that says rain, and it rains. So and the character is also made up from characters. It's a character of character. Yeah, it has a lot of character. And you may have played one of the hardest games of all times. It's called Dwarf Fortress. For decades, this was text only. It was character graphics, like many games in the 1980s used. They did not have sprites and characters and drawn things. They made a font that looked like your tiny figure, that looked like a wall. If you've never played one of those, Once Upon a Bike people, a few meters ahead, they have all those to play and to show. So go there in between talks, use those 15 minutes, check out one of those games and see how they used text as game. There's also movies. Who likes movies? You like movies? Have you seen WALL-E? Yeah? If you haven't, it's a computer animated science fiction romance, I'd say. It's a romance. It clearly is. And WALL-E, the main character, is a cute little robot who cleans up the world with their cockroach friend. And there's probably not a lot of dialogue, at least in the first half an hour or so. But that movie has a lot of typography because it spans eons of time across the world. So you can see in the typography of signs in the background and everything that something is old by the typography it uses and something is modern by the typography it uses. It's really beautiful. There's a ginormously long blog post about WALL-E being typeset into the future, with the evolving of a fictional brand in the movie, in the past and in the future, with how their logo and font evolves. It's really beautiful to see. And there's another movie. It's called Helvetica, like the font, and it's about Helvetica, the font. It's a documentary, and it's literally about how that font came to be, and like it's everywhere. It's really everywhere. There's tons of companies using that in their logo, in like any type of branch, whatever they do. So that's quite interesting to watch. I can recommend seeing that one as well. And since everything has to contain artificial intelligence these days, huh? Mm-hmm. Fonts are Turing complete. Would you want to chat with your font? I'm not entirely sure how this goes now. Please bear with me. I have to explicitly say thanks to Luto for helping me with the demo. We were driving to Novi Sad, and he was sitting on the passenger seat with his open laptop and compiling things on x86. My laptop is ARM. We redid the same thing on ARM64. So, yeah, I should remember that password. I did. You see two text documents. You don't. Why don't you see that? Because I see that. I should be putting that over here. No. Now you see two. Yep. It's a text document. You can type things. Yeah, okay, that's not worth an applause yet. Okay. Take a font. For example, Open Sans. I type Open Sans, Llama Sans. Somebody put a large language model into a font, because fonts are Turing complete. So you can type the letter O. If you want to check what I'm typing, it's the letter O, not a Swedish Ö, but it makes Earth. So I cannot type hello, I can only type hello. Unless I say abracadabra, then it's hello. And the font decides, it's a font, the font decides that it's done that way. Okay? So, let's ask the font to tell us the story, won't we? Once, I cannot type, upon a time. And then we just bang the keyboard for a little while. Yeah. For a little while more, like, okay. Then some. Now it gets interesting. Whoops. They're gone. Then if somebody wants to check, I'm literally just pressing the exclamation mark now. Once upon a time, there was a little girl. Named Lily. Full stop. She loved to play. Come on, tell me what? Outside. She loved to play outside. Tell me. In the sunshine. Oh, yeah. Okay. Lily loved to play outside in the sunshine. That's nice, dear little font. I am... Hello? So, I know how to copy-paste with the keyboard. It's just so that you can follow me. Yeah. Copy. And this is also a simple editor, but it does not use a large language model inside the font. And you've seen I've done nothing in between here, and I should be able to paste, unless I'm not. It's just exclamation marks. If you were to print from the upper document, it would just print exclamation marks, because the font just decides to render the exclamation mark glyph as a word that the large language model inside tells it to. So if you want to have a conversation with the font, or can think of other attack surfaces inside your font that you might want to use, for good purposes or nefarious ones, whatever your head says, there's some inspiration. So, that concludes this live demo. Give me a second. The slide says wrap up. I have no idea what I'm doing. Yeah, tools. I'll show you a few tools that might help you with dealing with fonts in your future life. I'm already sorry that I told you about keying. For macOS, there's a tool called Font Goggles. You just drop a font file on it and it tells you a lot of stuff about that font. Like what properties does it have, which axis can I adjust in my CSS, many, many things. If you don't have a Mac, fear not, there's Font Drop, does pretty much the same thing. And you can also play with the sliders in your browser. Like slide things across and adjust things and see what happens and how typography looks like. There's also Wacom Fondue. It's another tool that tells you a lot about fonts. It will not upload that font to the server. It runs purely in JavaScript locally on your machine. So that's also a nice property for you to have if you're experimenting with your helpful exploits. So, yeah. I missed that one. Let's go to that one. Thank you to all the volunteers at BalCCon for keeping this conference running, for supporting me on site with all my stupid ideas, and taking care of me by actually bringing me food and making sure I drink stuff. So I'm alive because of you. Thank you so much for that. Really, I mean it. I could not have done it without you. And also thanks to all the people who have helped me in advance preparing for this, if you call that preparation. In no particular order, Columbia, thanks for your expert knowledge in fonts and typesetting and answering my peculiarly obscure detailed questions that are not relevant to this talk, but I was really curious to find what's inside that rabbit hole and looking that up for me. Thanks to Tech5 on printables for their research on 3D printing fonts and labels and stuff. The tiny cards that you spread across and look at. Thanks to Sof from Gebärdenwurst for expert knowledge on signed languages and a lot of valuable input on 3D printing. To Lobbe of the Typographic Society in Vienna for making sure that some of these explanations actually make sense to anyone, including me, and that I don't miss some of the most important aspects. Thanks to Josp of the Do It Blind project for telling me about the dot encoding on 6 and 8 dot braille and how that works. And there's control characters where you switch between characters and digits and you switch back, but you have implicit back switches as well. So it's basically WordStar in a type. It's very interesting. Thanks for Aram for their expert knowledge in Hebrew, because I would not have been able to check if that Hebrew type is correct, and they said yes. Again, thanks to Lutu for letting me nerd snipe you over and over again into hours of compiling stuff to make that demo possible at all, because that really wasn't really easy. And also to everyone here who had fun playing with the table, where I just dumped a bunch of letters last day. And I took a few pictures. There were really creative ideas on what you could do with characters, and like, oh, I want to have a greater than sign, but I don't, so I use a V and turn it around. People were really creative and had lots of fun seeing what you come up with, including many ideas that I would have never gotten. And also, congrats to the person who actually solved the riddle at 2 in the morning. Kudos. I guess you can still see it. If not, mix them up, create something with it. Yeah, sorry for the evil challenge I put on that table. I hope you still had fun with it. Can we do questions? Is there? Yeah. Yep. Damn, I had hoped I could get away without. Thank you. Questions? There's one. Nope, I'm not getting away.
Hi, thank you for the great presentation. So I'm curious, so do you maybe understand, like, so you mentioned that fonts are Turing complete. Like, do you maybe understand what we lost if we dropped that, power of expressiveness to something, to something that is not Turing complete, to something less? So why did we need Turing-complete fonts?
Well, there's a lot of decisions a font makes about how it renders or shapes a glyph. And that, as we've seen with the ligatures, that depends on the font knowing which character follows another one. And that decisions need to be made by the font. They're just executed by the render engine and the font shaper. The information, how that is done, the code, how to decide this, is in the font. So if you lose that, you lose a lot of typographic fidelity. You can get by with ASCII, but try Serbian with ASCII. You might end up with some oddly ambiguous words, intentionally or not.
Right. So I'm also interested, like, probably governments would be interested in having, safe fonts.
Can you repeat it a little louder, please?
So I can imagine that governments would be interested in having safe fonts in the sense of security.
Yeah.
So, like, do you maybe know off the top of your head, are there any fonts considered to be safe?
So the question is, are there any safe fonts
or government approved?
For
let's
high security environments?
Yeah.
If we want to sum up that, I do not have a recommendation, like a specific typeface that you could use, but the fewer features a font has, the more luck you may have with it not being dangerous. But some measurements you can certainly take is, like, prohibiting web browsers to load remote fonts by default, which is the standard. Because you're literally loading a font with all the features from the internet. We've seen variable fonts. They can really help make great typography in a web page, but they can also introduce a lot of additional value-added functionality to your web page. So something easy you might be able to roll out is like no web fonts.
Thank you.
So one addition to this, I'm using a lot of font stuff or layouting stuff in my job, and there are a lot of characters that I'm not allowed to put on the thing that I'm doing. So you can filter out the characters that you're using and limit them to actually Latin or something like this, whatever you have, but you can just select the characters that are allowed to be used, and by this you can reduce the effect that this can have somewhat. It's one way. And another addition, if you go for the accessibility way that you do, you can actually save your company a lot of money, because you get way less questions for your customer support, and by this you can reduce the number of people you have to employ. So this is a very, very effective thing if you use the correct font for your documents or whatever you are using. And actually I had this in one of my customers. They actually made, they monitored what they were doing, and they changed the font and some other things, and they actually saved a lot of money by this. So it's important, even the accessibility.
Yeah. So it boils down to being able to use the typographic subset of a specific typeface and limit the features and the attack surface that way. And the other thing is you can save, as a company, use the wrong motivation to do the right thing, meaning getting away cheaper for better accessibility by reducing your support costs, or fines if you're not matching accessibility compliance rules. Please do it for the right reasons as well, but do it. Yeah.
Hi, lovely talk. I might have missed your explanation in the demo, but why did the top text editor actually render the story and the bottom one didn't? It looked like they were the same font. Were they not? Or
they were not. The top editor was using Llama Sans. If you type Open Sans, which it is based on for actually showing glyphs, I type Open Sans and it replaces Open with Llama. And the other one was just a plain font that does not have a large language model inside. That's also why it's quite slow to react, and yeah, I'm going through a VM on, yeah.
Don't know if you've played around it, maybe for the next iteration of the talk. You can embed fonts into a PDF.
Yes.
You can digitally sign a PDF, which would be equivalent to a manual signature. Could you have the font? Could you have Luto to create a font that puts out something differently if you show it on the screen than when it gets printed?
Yeah, that is already
and it would be digitally signed.
Having a PDF that shows different on screen than on print is a base functionality of PDF already.
Yeah, but so PDFA, which excludes those things.
Guess why? Yeah, there's different PDF versions, like PDF/A for archiving purposes, which removes a lot of the functionality of PDF for the purpose of being easy to parse in like 30 years when we have computers that work kindly differently. So there's reasons why they reduce the feature set to make it easier to parse and to archive and keep information available for longer times, but also to reduce the problematic surface. And I would not be surprised if there were already digitally signed invoice PDFs that, like, if you miss the payment deadline, they would automatically add like your fees on top. No, if you print them again.
Just by using the font.
Yeah, yeah. That would entirely be possible. And yeah, you can get creative with governments and digitally signed documents in that way, I would assume.
Okay, from this demo that is shown, is it then possible to filter some words within the font? Font is used like a rendering of what words can you type in the editor.
I'm not sure I understood the question. Can you speak up a little, please?
Can you, for example, type some word? I don't know, you type a word question, and then to delete that word because it's not in some dictionary that you define.
For the demo, this is basically a hard-coded dictionary for the demo that I showed, but there's not really a limitation to what you could use.
So you can make that limitation for...
You can create the limitation on your own, you could remove it.
It's like
it just becomes really, 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 really slow.
Yes, okay, thank you.
Because every time you type another character, it has to like calculate a whole language model on the whole text. So.
So how possible would it be to make something like the Tom Riddle's diary from Harry Potter with this? Because you could ask a question and the renderer could just erase what you wrote and wrote something different.
Basically, yes. The large language model demo is done with the Harfbus glyph shaper, and you can plug in WebAssembly in there. It's not the default compile option, so rest assured, not yet. But you can put anything in there. And there's, I guess, cross-compilers from any language to WebAssembly, be it Rust or COBOL. So it's compatible with banks and insurance companies as well.
Hi, great talk. You answered half of my question, but the other half is, are there any limitations to like the size of the code you can package in with a font, or can you just go like do anything you want? And you know, I mean, the person might notice that it's like a gigabyte, but
that font file is about 60 megabytes already, and that is quite large. So on a website, probably easy to trip and recognize. In a PDF that's a few hundred pages, you might get away with it, depending. Experiment with it. Tell us about it next year.
All right, thanks.
You mentioned a couple of writing systems where they can be written in different directions, and the first challenge is actually to figure out where you need to start reading the text. Do you know if there's, I believe kanji was one, do you know if there is something like kanji polyglot poetry where you can read the text from all the starting points and you come up with different poems or something?
The remainders of my Japanese knowledge are not enough to deduct that, but I would expect this to exist. I would not know why it wouldn't, because it's an obvious thing to try.
Yeah, that's what I thought.
Like a palindrome in a Latin alphabet that you can read both ways and it becomes the same word. Yeah, sure. There might be poems that have two different stories to tell depending on which aspect you use for the direction.
I'm gonna do one myself. You mentioned that if we were to print the LLM output, that it would not print, but why? If we use the same font, wouldn't the printer also interpret the LLM, or?
I doubt the printer does have a WebAssembly shaper.
That's fair.
Yes. If it has, you know what to do with printers. But it's an interesting aspect. We can try afterwards. There's a printer on site. If they let us try this.
I will add to that. Should you then see if you do a print preview?
Good idea. Yeah.
Should that show you what will be printed actually?
Am I brave enough to try? Yeah. Cool. How do you do a print preview on Linux? I have no idea. You?
Control P.
Control P. You really think that's work? Okay.
Because there was a print. If you go back to the menu.
Yeah.
Oh, there we go.
Print to.
Preview. Top right.
Yeah.
Top right preview.
Oh. Okay.
There's your answer.
All right. Any more?
Great idea.
All right. Thank you, everybody. If you come up with something, please here.